गुड मॉर्निंग स्टूडेंट्स, गुड मॉर्निंग बच्चों ऑल ऑफ यू। कैसे आप सब लोग? मस्त एकदम। ओके, आई एम योर गाइड केमिस्ट्री लेक्चर सीके सर। ओके, इन लास्ट क्लास we studied about equilibrium constant for Nernst equation and some related problems on that. Okay, but in today's class we are learning with very best concept in the one of the best concept in electrochemistry, that is electrochemical cell and free energy change. Okay, so what is the meaning of this one? Already you know what is the electrochemical cell. Okay, see, which is converting, it is a device. Okay, this is a device which convert chemical energy into electrical energy. Now sir, again why we are going to be studying, we are seeing how this electrochemical cell and free energy are interlinked. Okay, कैसा है interlink है दोनों? Okay, let's see. Not only we are just going to be seeing the interlink, we are deriving a expression. Okay, a final expression we are going to be deriving, which is the explains how this electrochemical cell and free energy change are going to be, both are going to be in a very fine manner. Okay, that is going to be represented by an expression. See here, a electrochemical cell in the sense it is a one of a component or a device which convert chemical energy into electrical energy. Now whenever it's converting chemical energy into electrical energy, साइलेंटली नहीं होता है, वायलेंट करता है बेटा। कौन सा वायलेंट? these are creating redox reactions. Okay, simply this is not undergoing, these are undergoing the redox reactions. जब भी redox reaction होता है तभी free energy अंदर आता है. Okay, in the sense during the redox reaction a free energy is going to be liberated. This is a free energy. Okay, जब भी free energy आता है तभी क्या होता है? The free energy is in the form of electrical work. We can use this free energy in the form of electrical work. Okay, electrical work. Okay, based on this only so many electrical devices we are going to be running. Okay, so now this is motor E nothing but we are converting this chemical energy into electrical energy. If I am going to be writing, okay, मैं क्या बोला बेटा आपको? electrical work, chemical से electrical हो रहा है बोले तो उधर redox reaction चला है. Within that redox reaction free energy is going to be liberated. That energy is used for the electrical work. That energy is used for the electrical work or work done. Now see what happening here. I am representing this one in terms of the some symbols. See here, delta G, delta, take here W max. First of all, W max is equal to minus n या E cell. सर W max बोले तो क्या है बेटा? मैक्सिमम इलेक्ट्रिकल वर्क. ओके, मैक्सिमम इलेक्ट्रिकल वर्क नथिंग बट जो भी फ्री एनर्जी मिल रहा है मैं उसको लेके कितना ज्यादा मैं इलेक्ट्रिकल वर्क कर रहा हूं, दैट इज W max. This is W max. I can also write delta G. Okay, delta G is equal to minus n या E cell. Okay, in the sense delta G is free energy, n is number of moles of electron, F is the Faraday, E cell is the electrode potential or EMF of the cell. Okay, after the knowing this point, see here, so delta G n E F is okay. Okay, now among this which one is the intensive property, which is the extensive property? Okay, see, the delta G is extensive property. Okay, this is a extensive property. This is E cell is a intensive property. Okay, sir आप क्यों बोल रहे हैं? Okay, within this expression we are derived. Okay, this is extensive, this is intensive property. Okay, first of all what we are done, just electrochemical cell and free energy. Within this electrochemical cell free energy change or free energy is going to be came, that free energy used for electrical work. Okay, now that electrical work I can represent in the form of the whole whatever the process, W max is equal to minus n at E cell. This W max I can write delta G. Okay, within this delta G is extensive property. Sir, what is the meaning of this one? Sir, आप ये extensive intensive हमारे को कई को बोल रहे हैं. What is the reason behind? देखो बेटा, this is a very basic thing where we should learn the extensive and intensive properties. Let it down. Extensive property nothing but this is a extensive property. Okay, Extensive property nothing but which is a depend on. Okay, it is a depend on. It is a depends on the property of the system. Okay, it is a depend on the property of system. It is a depend on. I can write also. It is a depend on matter which is present in the system. Okay. In thermodynamics in first year also you know inside the system, outside the system. Okay. It is a depends on the matter which is present in the system or inside the system. For example, extensive property delta G nothing but free energy. Okay, entropy, enthalpy. Okay, these all are examples are belongs to extensive property. बोले तो these are the special property, extensive property where the delta G is the extensive. It is a depend on the matter which is present inside the system. Okay, like take the same extensive property. Extensive property. In this extensive property, what is we are going to be taking? It is a not depend. Okay, it is not depend. Okay, matter. It is not depend on the matter. Okay, which is present inside the system. Which is present inside the system. For example, I am going to be considering now surface tension, which is the best. Okay, density, volume, surface tension. Okay, surface tension. These are the things, these are the quantities which is not depend on the nature of whatever, the nature of the matter or the nature of matter which is present inside the system. ये depend करता है, depend नहीं करता है. The final conclusion is delta G is the extensive, E cell is the intensive. Simple. Okay. And see at the last one more important point. This NF I can also say this as a number of charges are going to be moving. Okay. The whatever the charges are going to be total number of charges I can say by this terms. This is a simple. Okay na? Now one more important here. Sir, how I can say this is extensive? By using this equation, I will tell you this is a extensive property. Okay, how? First, copy down this one first. Over now, or take screenshot. Let's see. In this concept, how we are going to be proving that? Sorry, this is name. This is a intensive. This is intensive. Okay. This is extensive. This is intensive. Make this as ion. Make correction here. This is intensive. Okay. Now, by using this equation for a Daniel cell, okay, for a Daniel cell, I am taking Zn2 plus Zn2 plus double bond. This is in the sense this is the hyper, double hyper. Cu2 plus Cu. This is for Daniel cell. Okay. See here, I am writing delta G is equal to minus NFE. Okay. A 1 mole of zinc is having 2 mole of electrons because Zn plus 2 transferring of 2 mole of electrons. So delta G is equal to minus 2 Fe. This is equation 1. Now take up second one. If I am going to be making delta G is equal to minus NFE, I am taken here, okay, 1 mole of zinc. If I am going to be considering for again Daniel cell, this is a 1 mole, this is a 2 mole, 2 Zn2 plus, 2 Cu2 plus, this is Cu. Okay, this is I can write directly. Okay, now what I can write this reaction? Delta G is equal to minus NFE, delta G is equal to minus This is 2 nothing but 2 mole of zinc is releasing how much? 2 mole of zinc releasing 4 electrons. Nothing but here 4. E, F, E. This is a simple one. If I am going to be comparing this equation, the 1 and 2, if I am going to be comparing this equation 1 and 2, the change in number of electrons are different. Okay, while comparing equation 1 and 2, we can conclude that delta G is extensive property. Sir, how this is extensive property? Let's see. If a number of electrons are going to be changing, the delta G value is going to be changing. It's a depend. Okay, this is a depend on the nature of the matter which is present in the system. अगर delta G को effect हो रहा बोले तो overall matter को effect हो रहा है. This is affect matter affect the system. Okay, totally this is going to be changing. So that's why this is a extensive property. Okay, take down fast or take screenshot. Now see, we are now seeing the important, that is how we are going to be deriving the free energy. Okay, that is the free energy from the electrochemical cell. Okay, electrochemicals. Now the relationship between standard gives free energy. Whatever that energy is coming, which is we are going to be using for electrical purpose or electrical work. Now in between the delta G and equilibrium constant, that is Kc. Okay, how we can derive this equation? Okay, very simple. See, we are stated that E naught of cell equals to, we are having, okay, RT divided by NF ln Kc. If I am going to be converting 2.303 RT divided by NF log Kc. I can write like, okay, this is for what? This is what? 2.303 RT divided by NF log Kc. Okay, we are going to be writing the Kc, nothing but we are going to be writing for what? Equilibrium constant equation. This is standard one. Okay, I can write here delta G is equal to minus N F E cell. Okay, this is a one more, which is a free energy change. It is a free energy change. By combining these two, I am writing the relation between the standard Gibbs free energy, that is take as delta G is equals to, okay, delta G and the equilibrium constant. Use the equilibrium constant minus RT, okay, ln Kc, okay, minus RT ln Kc. This is the standard value. After deriving these two, I am going to be getting, this is final one. Okay. Further, if I am going to be simplifying, what I am going to be getting? See here, delta G is equals to minus 2.303 RT log Kc. 2.303 RT log Kc. This is our, this is T. Okay, this is a T value where we are going to be studying. Okay, relationship between standard Gibbs free energy and just I am taking this one. Okay, whatever the NF, whatever will be there, we are going to be putting it unity, and we are going to be getting delta G is equal to, okay, delta G is equal to RT. Okay, RT nothing but RT ln Kc. This is a simple. Okay. By this one, if I am going to be removing the ln 2.303 RT log Kc. I am writing one more time here, clearly see. Delta G is equals to minus 2.303 RT ln, this is log, because we are taken 2.303 now, log Kc. This is a final expression. By using that, we are going to be solving the problems. Okay. Now, based on this, we are having problems. Okay, we have to solve some problems. Now see, I am taking first problem, that is the standard electrode potential for Daniel cell is 1.1 volt. Already we know, because Daniel cell, what going to be happening here? Zn plus Cu 2 plus Q is raised to Zn2 plus Cu. Okay, this reaction is going to be happening in the Daniel cell. Okay, already we know. And the standard electrode potential, nothing but standard electrode inert cell, how much this is? 1.1 volt. Calculate the standard Gibbs free energy. He wanted to ask delta G. What is the value of delta G? Okay, उसने क्या पूछ रहा है? Delta G का value पूछ रहा है. He is given what? Inert cell. Okay, let's start this. Take first formula delta G is equals to. We have to substitute this formula. Okay, हमारे को ये formula को put करना है. Sir, reason क्या है बोले तो? We are not. He is not asked any the equilibrium constant. Okay, he is not asked the equilibrium constant. So I am not putting this. Okay, this last expression. Just I am putting this one. Delta G is equal to minus n ya e not cell. Okay, calculate standard nothing but I have to take the distance. Okay, now minus n nothing but what? 1 mole of zinc is having 2 of electron because 2 electrons are transferred. Plus 2 nothing but 2 electrons. 2 into Farad nothing but what? 96,500 coulomb. Okay, into what is the inert cell? 1.1 volt. Okay, keep in remember one more point. This is coulomb and volt are became joule. Okay, 1 mole of coulomb, 1 mole of volt is whenever it's going to be generated, I can say that is a 1 joule. Okay, now after the calculation, delta G naught value will be calculated. Tell me first, what is the value? Minus 21227. Okay, 21227. Okay, this is what a joule per mole. Okay, joule per electrons in terms of, if I am going to be taking mole, this is nothing but joule per mole. If I am going to be converting into kilojoule, how I can write? Delta G naught is equal to kilojoule minus 212 because 3 digits. Okay, 27 kilojoule per mole. Okay, this is a important thing. Now see, if I am going to be taking here minus, say minus because reaction is feasible. This is spontaneous, nothing but जिधर भी delta G negative रहता है वो spontaneous रहता है. That is a reaction is possible. वो reaction हो जाता है अपने आप से. Okay, that's why we are going to be taking this one. Okay, nothing will be there. And such problem, in this problem, the standard electrode potential of Daniel. He is given standard electrode potential. He wanted to ask to calculate standard Gibbs free energy, nothing but delta G. Okay, देखना इधर. Okay, इधर तो Kc दिया क्या नहीं. Okay, among this one, which one we have to use? Have to use this one simple because he is just asking a delta G. Okay, he is given n, f, everything will be there. Okay, n is 2 electron. How it is came means zinc is going to be liberating 2 electrons. That's why 2. Okay, now f nothing but Farad standard 96,500. Inert cell already given for Daniel cell. We are having inert cell is 1.1. I am substituted, I calculated, I am getting this much. If I am wanted to convert in a kilojoule, that is 212.27 kilojoule per mole. More for electrons, that is 2 more of electrons. And whenever this coulomb and volt is converted, I am converting that one into joule. This is one. Okay, take down or take screenshot first. 1, 2, 3. Over one. Now see, we are dealing with another problem. This is a very special. A cell is in which the following reactions are. Okay, is given one cell. The reactions are going to be occurring. Okay, and has inert cell is given inert cell value 0.236 volt 8298 Kelvin. Calculate the Gibbs free energy, and he wanted to ask us delta G and equilibrium constant. Equilibrium constant also is going to be possible. Okay, now see, let's take what are we given first solution. Inert cell is given standard one, that is 0.236 volt. Okay, and also is given the there is nothing is given. Okay, see first at temperature 290. Now see, first I am applying delta G formula. Okay, delta G already you know. My delta G is equal to minus n ya e cell. Okay, minus n e cell. Okay, calculate Gibbs free energy first. Okay, see in this how many electrons are going to be transferring? Transferring of electrons are how much? 2 plus F nothing but already we know F nothing but Faraday 96,500. 96,500. ESL is how much? Already is given 0.2364. If I am going to be calculating, how much I am going to be getting this one? Tell me. Minus 45548. Okay, this is electrons in the terms of moles. Okay, this is coulomb and volt will coulomb and volt and this is became joule. ये दोनों combine होके joule होता है. This is and this I can say right here joule per mole. Okay, this is a joule per mole. This is the first one. I have gotten what now? Delta G. Okay, now I have to substitute that is a value. Okay, which is the value? I will substitute value in this one in the equilibrium constant. What is the formula of equilibrium constant? Let's see. What I can write here? Equilibrium constant delta G naught or delta G naught is equal to minus 2.303. Okay, tell me R. Very good. RT log Kc. Okay, log Kc. What are the value I know here? First of all, take that one. Okay, delta G बोले तो हमारे को क्या है? Delta G already I come to know. Okay, I have to find now here Kc value. Okay, मैं Kc को कैसा लिख सकता हूँ बेटा? Kc. Okay, see here. I can write Kc as I am writing here. Kc equal to delta G naught divided by minus 2.303 or T. Okay, whatever the log will be there, I am writing log here itself. Okay, log Kc. Okay, because both are combined I am taking. Now substitute the values. What is delta G naught value? Already we come to know what is the value. Okay, if I am writing here delta G naught. Okay, this is delta G naught. Okay, standard energy. Minus 2. First delta G value is delta G naught 45548. 45548. Okay, 45548 divided by again here one minus is there minus 2.303 or nothing but 8.314 into T is 290 Kelvin. Okay, if I am going to be this is minus became here positive will came. Okay, first of all, and what is the answer? Answer is 7.92. Okay, answer is a 7.982. Okay, take calculate into this one. Okay, 7.92. Okay, whenever this is a log Kc value. Whenever Kc and log is come here, this is became anti-log. Anti-log of 7.98. Okay, 7.2 remove. I am taking 7.92. Okay, now Kc equals to anti-log of. Okay, I can write this as a 7 plus 0.98. Okay, simply log 7. Okay, बेटा मैं log 7 को कैसा लिख सकता हूँ? Okay, log a power b value. Okay, log a power b, log 10 power 7. I can write as 7 log 10. Log 10 is 1. Again this value is became 7. Okay, so I can write here log 10 power 7 plus log of 0.9. इसको ही लिख रहा हूँ मैं, कुछ भी नहीं कर रहा हूँ. Just I write this 7 को मैं 7 लिख रहा हूँ. I can also write 10 power 7 को कैसे लिखता हूँ? 7 log 10. 7 log 10 nothing but 7 only. बस 7 को मैं कैसे लिखता हूँ? Log 10 power 7. Okay. If you are having confusion, let's take this one. Okay. कैसा आप लिख सकते हैं बोले तो log 7. Okay. Log 7 plus log 0.9. ऐसा भी आप लिख सकते हो. Okay, this is just for your understanding purpose. Okay, I am written like now. Kc is equals to anti-log of log a plus b nothing but log a into b formula. Okay, log of 10 power 7 into Okay, 0.98. Okay, log 0. I have given one table, special table. Okay, 0.98 किधर आता बेटा? Okay, log 9. Okay, 0.9 बोले तो 9 के 0.95. Okay, उसके भी ज़्यादा आगे नहीं but 9 point. I can write 9.4. 3 or 4. 9.4 the value. Okay, now this anti-log log get cancelled. Kc value is 9.4 into 10 to the power of 7. Okay, this is a value 9.4 into 10 to the power of 7 is the value of a equilibrium constant. What we have done in this problem? Nothing. The cell in which the following reactions are. Okay, he is given one reaction. Okay, and that is having E naught cell is 0.236 is given standard electrode potential, and he wanted to calculate Gibbs free energy equilibrium constant. First write down all these values. Okay, apply the first formula for delta G. We are going to get in this value and apply for equilibrium constant. Make KCS outside and write as per delta G value we know, or P value also we know. I am getting 7.982. Okay, log Kc will be there. If I am going to be sending log to right side, it became anti-log. Kc anti-log. Apply log A plus B formula. We are going to get the final this equation. This is about one of important problem. Okay. Take or make screenshot first. 1, 2. Now see the third one. Calculate change in the free energy for the cell. Okay, he wanted to ask me delta G. Okay, can you hear my voice? Delta G. Now delta G, what is given? Okay, he is just given. He is not given E naught cell also. Okay, he is not given E naught cell also. Now for this reduction is going to be takes place as a oxidation at a magnesium, reduction at a silver. Now, first of all, we have to calculate delta G value. In order to calculate delta G value, we require what? Minus N F E naught of cell. Okay, if I wanted to calculate standard one, G naught. E naught cell is not given. See in this formula, it is never given E naught cell. Okay, but is given. Clear that standard electrode potential of 2 electrodes. Okay, one is cathode, another one is anode. By using that, I can calculate the E naught cell. See here, first one. E naught of Ag plus Ag gives rise to 0.82. Okay, E naught of Mg 2 plus Mg's value is what? How much? Minus 2.37 volt. Okay, and later I am going to be calculating first. Okay, first I am going to calculating this one. Number of electrons how much? Mg plus 2 nothing but 2 electrons. Okay. F also we know 96,500 coulomb. Okay, just we have to calculate this one and this one. This problem. See, E naught of cell E naught of cell is equals to first I am going to write about E naught of Ag. Okay, E naught of Ag plus Ag minus E naught of Mg plus 2 Mg. What is the Rm value here? 0.8 minus Mg value is, take down this one, this is only now minus 2.37 volt. Okay, combine this one, what happens? Plus 0. Both are combining 3.17 because this minus became plus. Okay, this is a E naught cell value. If I am going to get in E naught value, I know F value, I know E value. Now I can go for free energy. So here delta G is equals to delta G naught is equals to minus N nothing but 2. F is 96,500 coulomb into E naught cell is 3.17 volt. I told you 1 volt plus 1 coulomb become 1 joule. This two became 1 volt, 1 coulomb is became 1 joule. Okay. Now at final the standard free energy will be, I can write as minus 611.81 kilo joule per mole. Calculate, you are going to be getting same value because just substitute value N nothing but 2, F is 96,500, E naught value is not given but we are calculated that one, that's value is 3.17. If I'm going to be doing, we are getting 366,181. This is actually 361,611. Okay, minus 61180 kilojoule per, sorry, joule per mole. This is when I am converting them to kilo, I am getting 611.80 kilojoule per mole. Okay, this is what you are asked. Okay, take them first. Take this one first, all of you. Now see, in this last problem, we are seeing given E naught of A plus 3 nothing but is given two standard electrode potential or inner is given two values. Okay, and is telling that construct a galvanic cell. Okay, and using these two electrodes. Okay, and calculate the standard free energy and also calculate the equilibrium constant. Okay, is given a problem. That problem is consisting of what is written first two standard value of aluminum and magnesium are minus 1.66 volt and minus 2.37 volt respectively. He is given two standard electrode potential values of magnesium and aluminum, and he is telling that construct a galvanic cell. He wanted to tell what construct the galvanic cell. Okay, एक कैथोड एक एनोड लेके हमको हमारे को रिएक्शन लिखने का है. Okay, and calculate standard free energy. He wanted to ask delta G. Free energy in the sense delta G no standard, and just cell reaction and also calculate equilibrium constant. He wanted to calculate equilibrium constant also. Okay, first of all we have to find delta G naught, next Kc value, and we have to write cell reaction also. So example, when we are comparing this both two, which one is anode, which one is cathode? Okay, anode is which is having less value. Okay, that is an anode. Okay, for example, I am taking magnesium as a at anode. Okay, cathode. If I am going to be combine and write the cell reaction, this is became this see 3 Mg plus 2Al3 plus it gives res to Mg2 plus 2Al. This is a solid, this is aqua, this is a aqua, this is a solid. Okay, I can write this reaction. Okay, I am writing this cell reaction for this particular problem. Okay, because at anode oxidation, at a cathode reduction is going to takes place. And now next value. See here, orally how many electrons are going to be passing? That is N is 6 electrons are transferring. Okay, 3, 2, okay, plus 3, aluminum plus 3, magnesium plus 2. Total oral electron transferred are 6 because this tendency is 3, this tendency is 2. Now, next, I wanted to calculate here E naught cell also. Standard electrode potential because I am having 2. So, first my priority is calculating E naught of cell. Okay, E naught of cathode minus E naught of anode. What is the value of cathode? Cathode in the sense what? Aluminum is cathode. Okay, what is given value? Cathode का क्या है बेटा? Minus 1.66 of minus into minus again these are what happened? Plus. This value is plus. Cathode का कितना है? 2.37. Okay, overall what is the value is coming this one? Tell me first, what is the value? 0.71 volt. 0.7 E naught cell value. Okay, this is a E naught cell value. Now when I am getting the E naught cell value, it is very easy to calculate the delta G value. Okay, delta G, what is that? Delta G is equals to minus NF E naught cell. Okay, delta G naught I am taking. N nothing but I know. I told you 6 electrons are transferring 6 into 96,500 into E naught cell value. I come to know 0.7. If I am going to be calculating these whole things, I am getting what? Delta G naught value. Calculate 4,111 put down 4,111.09 kilojoule per mole. Okay, Actually this is coming 4,110,9,314. I am converting this one to kilojoule. Actually this is coming joule. I am converting kilojoule. Okay. This is a value. Okay. I am getting now delta G naught value. Now I wanted to calculate now for an equilibrium constant for Kc value. What I can write? E naught of cell is equals to, okay, E naught of cell is equals to, tell me, 2 point, first of all what I am write? Okay, take first completely the equilibrium constant. Okay, that is E naught of cell. E naught of cell is equal to 2.303 RT divided by NF log Kc. Okay, what are the value I am having? Just see. Okay, I require this Kc value. Okay, I am taking this is outside. Log Kc is equals to E naught of cell into NF divided by 2.303 RT. Say yes or no? Okay, like I am going to be right. Substitute one by one value. E naught cell value you know already 0.71. N is 6 electrons. F is 96,500 divided by 2.303 or nothing but 8.21. Okay, 8.31. This is a gas constant. Temperature is 298. Okay, if I am going to be making calculation of this one, I am going to getting 72.05. Okay, this is a log Kc value. Okay, nothing will be there. Just to make multiplication by using simple calculation. Okay, if you are having calculation, just calculate this. You are going to be getting what? This is 8.31. Okay, this is the universal gas constant. 72.05. See, I am putting the Kc as it is. Log when it's come here, this is became anti-log. Okay, already we are studied. I can write this as 72 plus 0.05. Okay, I can write this as in terms of two values. I can split. Okay, anti-log of, I can write this is a log 10 power 72 because its value again 72 log 10. 72 log 10 का value 172 again. Log a power b, nothing but b log a. According to that, I am writing here log of 10 power 72 plus log of 0.05. Okay, simple. Now this is in the form of log a plus b, log a plus log b. Okay, log a into b, that is anti-log of what I can write here 10 to the power of 72 into log 0.05 का value क्या है? Log 0.05 value is how much? Okay, log 0 is 0. Log 1, what is the value? Log 1. Okay, tell me. Log 1 is 0. If 0 से भी थोड़ा आगे, I can take what? 1.1. Here I can take 1.1. Okay. Log 0 is 0. Log 2 is what? This is 0.3. Okay. This is in between. Okay. The log 1 का value क्या है? 0. थोड़ा उससे भी आगे, nothing but 1.1 I will take because log 0.0. According to that table what I given. Okay. Anti-log log it cancels. The value is 1.1 into 10 to the power of 72. This is the Kc. This is an equilibrium constant value. Okay. This is the problem. Okay. In such cases, he is not going to be giving delta G naught value. He is not going to be giving delta E naught cell. He is not going to be giving equilibrium constant. We have to find out all these three things. Sir, what happened here? Just he is going to be giving what are two standard electrode potential values and is also giving some hints that is about electrons. Okay, N is we are calculated because magnesium is plus 2 tendency, aluminum is plus 3 by combining 6 electrons totally. Okay, these 6 electrons. After I am going to be substituting all these things, we are going to be getting first at anode oxidation. I am writing here oxidation. Okay, here reduction is going to be takes place at aluminum, and while I am going to be combining these two, I am writing this cell reaction. This is also carries marks. Okay, so many problems he is asking the cell reaction. Okay, in this also he is asked using constructor galvanic cell, nothing but write this reaction also. And then later we go for A naught cell because he is given two values. We found at E naught. Next is delta G naught. We know E naught cell value now here. I am substituted. We are going to delta G naught. Later this is for R, for Kc, for equilibrium constant. We substituted value and I taken outside this one. The arrangement will be like okay, because NF into E naught. Okay, cross multiplication. Okay, 2.03. Substitute all the values. We are going to 72.05 log Kc. Log इधर आता है anti log and I can split 72.0.05. Okay, log 72 I can write log 10 power 7 according to A log A power D formula. Later 0.05 I can write log 1 का value कितना है 0. Okay, it's having log 0.05. Okay, 0.05 value क्या रहता है? Log somewhat 1.1. Okay, like I am taking log 0.01 का value 1.1. Okay, anti-log log get cancel. Log A plus log B in the form log A into B. Just I modify. Now 72, 10 power 72 into 1.1. Okay, anti-log log get cancel. Substitute direct form. This is case. Okay, these are some problems about the Gibbs free energy and the whatever the important concept that is equilibrium constant. Okay, these are some important problems. Like this type of problems are going to be asking in examinations. Okay, try. Still more problems we are sending in WhatsApp also. Some other problems also we will discuss later. Okay, okay. In the next class or that is in the next video we will come with the new concept. Okay. Until then, read okay. Okay. Do work at your home. Okay. Thank you.